Hello internet friends, I'm Chris. Welcome back to my lab. This is the second in a series of videos about the LED marquee project behind me, this digital signboard. If you haven't seen the previous video, you'll probably want to watch that one first. There will be a link in the description and some kind of card or something up here. That's where I explain what the thing is and how it works and all those details, so I won't be repeating all of that here. This video is about how it was designed, built, and installed. I think I'll do another one after this specifically about the code. This will be mainly about the physical construction and the electronics. Now, I prepared a whole explanation of what all these parts are and how I put it together and attached it to the wall and everything. And then I remembered that I recorded some video while I was putting this thing up. So I went and looked at that and I found out that I already have a pretty good explanation. And I think it's more interesting to see that while it's being done than for me to stand here and talk about all this now. So I'm going to hand it off to me from the past to cover most of the process, and then I'll be back at the end to fill in a few more details. So take it away. Actually, one thing. I want to give you a heads up. When I recorded this, I was standing here holding a camera, and I wasn't going from a script or anything, and I'd accidentally turned the stabilization on the camera off. So there's a lot of shakiness, and I tried to stabilize some of it in the video editing software, but not all of it because sometimes it crops in too much or introduces weird artifacts. So it's not great quality video, and I just, in case you were thinking of hiring me as a camera operator, this doesn't represent the best of my portfolio. That's all I'm gonna say there. So with that, take it away, exactly the same me. I have a whole bunch of these flexible LED matrices. These are WS2812B matrices that are commonly available and are relatively cheap if you buy them in bulk from overseas. So I'm going to string these together across this whole area here. There. And to hold them in place, and this is the part I've been manufacturing this for a while, I have laser cut these grids out of MDF, and it's got the openings for the LEDs, and then each matrix goes onto the back of one of those. I have it sort of gaff taped into place. That's step one, and then I have 3D printed these brackets to hold it to the wall. So this will go like that against the wall, screwed in through here, and then screwed onto that goes the grid itself. See, that's what it looks like. So this has the dual function of holding it against the wall as well as clamping these panels onto the back. They are taped to hold them in position, and then they're additionally clamped with the brackets. So 4 of those on each one of these, and then that will go against the wall. And in order to line all of that, oh, and they also have an interlocking mechanism here. So this is an end piece. It doesn't have an interlock, but on this side, they're designed so that they fit together like that. And that makes the spacing even and seamless across the whole thing. So it will act as one large panel. I have 3D printed a lot of these brackets. Then in order for that to work, I need to make sure that all of these brackets are precisely positioned. And so I've made a jig. That's this thing here. This is exactly the same as one of those, but instead of the matrix, it has the brackets on the back, but it has these holes cut out. So I can start here, I can put this up here and use this to decide exactly where it's going to go, and then I can get in through those holes, which go through there, in order to make the actual screw holes. There's going to be a total of 12 of these sections across the entire wall here. I've worked it out. I'm going to have what I'm calling 3 sections of 4, which we'll get to in a moment when it comes to how to control these. But so it'd be 3 times 4 all the way across, and it should fit just about perfectly. Because this side of the room here is obscured a bit anyway, it doesn't really matter that it goes to the exact end. I don't really care about that. And controlling it all is going to be an ESP32. This is just my test rig here with one of these connector boards on it, breakout boards. Now, the reason I say 3 sections of 4 is because when I set up the software and I tested this, I had it fully up and working with a single section of 4 of these daisy chained together. They have an in and an out. So by connecting 4 of these together, I was able to make a decent sized section of 1,000-ish pixels. Yeah, because they're each 256. So 1,024 individual pixels for one section of 4 of these. And I was able to drive that with a ESP32 off of 1 pin, good frame rate, no problems. So rather than, I could do the math on how many pixels you can drive at 800 megahertz or whatever off of this. I don't really care because I know that it works for 4. And so rather than press my luck, I'm not going to extend that 4 any further. I'm going to drive the next section of 4 off of a separate pin and the third section of 4 off of a third pin, and then use the parallel output that FastLED supports in order to drive them in 3 sections. But in terms of the software, they will be one long grid, but they'll be driven in 3 sections by the hardware. I hope that makes a little bit of sense. I also have a 18 amp power supply that I'm going to use, and this will be injected at 3 different places. If I drove 3,000 pixels at full brightness RGB, of course it's a lot more than 18 amps, but I don't care because I'm not going to drive these at full brightness. I usually run these at about 10% brightness, plus not every pixel is going to be lit. So it'll be fine. I will set up FastLED to limit the total current consumption, which is a feature that it has. So I think I can get away with this single small power supply. I also 3D printed. This I did not design. I found this on the internets. This is a DIN rail mount for this power supply. So that'll screw onto the back there, and then this will clip onto a piece of DIN rail. I think that's how I'm going to mount it. And then I'll run the wires up. And the other reason why I'm using these brackets like this is because it creates a channel in the back, spacing there, that I'll be able to run the wires along, and there won't be any visible wires for the thing. So I'll be back when this is finished. Okay, I got the first section of this up. It took a lot longer than I thought it would. The first time when I put this up, it actually has a bigger gap on that side than this side. And so I realized that by the next one, it would actually be running into the ceiling. So I had to do it again lower. So now I'll be able to use my jig here to sort of do the next section and keep going along that way. But I do have to keep that ceiling, I do have to keep taking that ceiling into account. Anyway, I've got to put up 11 more of those, so I better get moving. So the third one is going up easier than the second one. You can see here I have plugged it in. I wired it up temporarily just so I could confirm that the first 2 modules are working correctly. So that's that over there. And then I wanted to show how the jig works here, since I added up. So, like I was saying before, the idea here is that I can put that up, align it with this one using that interlock there, make sure everything's nice and straight, and then put the screws in. And then I can take this face off and leave the plastic brackets on the wall. I know that everything's going to be in the right place. I took all the screws out except the last one because I wanted to show this. I'm going to have a little trouble taking this off. There we go. With one hand, sorry. Bad camera work. But that's the idea, right? Then I take that off, and now I have those four brackets there. And then the next module can go right onto those brackets. So that's what I'm going to continue doing as I keep working my way down the wall. And after these two, that'll be the first set. So those get their own data connection. And then the fifth one will get a new data connection. So 5, 6, 7, 8 will be on a second data pin. And then also have another power injection at 5. So that's why I have these Wagos sticking out here, Wagos, so that I can run a cable through there and then take off with that and then inject it in at number 5. So far so good. We'll keep on keeping on. Well, I was going to say I got the 5th panel up here and yeah, so not quite right. I better go fix this. Just wanted to capture that since it looks pretty wacky. Well, it was a hardware issue, not a software issue. So here we go. I can finally say now that I have connected the first of the second section of this display. So over here, starting from the right, there are 1, 2, 3, 4 modules, and then this is the 5th module. And this is important because the 5th module is connected to a different I/O pin on the ESP32, and it's also connected, it has its own power feed. Yeah, it's hooked up, so that's the good news. What was wrong? Well, I, in my haste to just plug this in, I thought, sometimes you can get away with stuff, and I thought I could get away with just sticking the wire in there. It did need I put in a 68 ohm resistor for reflections, so I was kind of surprised. I'm not driving this correctly. I don't have a level shifter here. This is just off the ESP32's 3.3 volt output. I will, when I build the finished hardware, put in a level shifter and do the whole thing right, but this was, I'm just hacking this up to see how it works. Now you might be seeing what I'm seeing. I think you can see on the camera here. This is not perfect. It has a visible ripple there when it crosses the boundary between these two. So I'm not worried about that. If I have to swap the ESP32 and put in something else instead that's a little faster, I guess I could do that. Anyway, I'm going to continue. I still have a lot of wall to cover here. This is very, very slow going. And now I have to do the part that's behind this box, so it's going to be even more difficult for me to reach over there. But nevertheless, we carry on until all of the pixels are attached, and then we will worry about how to optimize the software so that it doesn't look glitchy. Alrighty, progress update. We've gotten to the other side of the pole here, so just gonna watch this message go by behind there, out the other side. So it's coming along. The process is working. So I got one section of 4, and then I got 3 out of the next section, so there's going to be one more, and then the third section of 4 will go over there. So this is it's all in, and I fixed the glitchiness. It is working very smoothly again. So before there was a very obvious seam between section 1 and section 2, and now there is not. And it was occasionally doing a little glitchy thing, and it's not doing that. So I think part of it is that there was an asymmetry. So I had it defined actually as 5 pieces, and so one of them was outputting 1,000 LEDs for the first 4, and then that 5th one was just 1 unit that was just outputting 256 LEDs. So I suspect the fact that it was outputting 4 times as many on one pin as the other probably had something to do with it. And the other issue is that I may have had the OTA updates enabled. So there's definitely something wrong with the Arduino OTA check that causes little hiccups. So I have my code now. Basically, I have a switch to turn that off and on, and it's off by default, and I just turn it on before I want to do an OTA update. So that being said, yeah, it's currently all set up. So this has the full 3000 pixel data buffer in here, which is why when this message scrolls across and hits the end, it's actually continuing to scroll through the invisible section there, which is good because that means this is testing with the full you know, full RAM usage and the full CPU usage to run the whole thing, even though that's physically not hooked up yet. It's spitting the data out on the pin, so I feel good about this. It'll keep up with the frame rate and everything else. All right, anyway, it's 12:30 in the morning. This is taking a very long time to put up, and I think I'm gonna call it a day, and I think I'll be able to finish this tomorrow. Okay, it's finally all installed and up on the wall. This is the last panel over there. So 12 of those matrix panels in 3 clusters of 4. And now the whole thing works. I'm tripping over stuff because it's such a mess in here now. But I gotta clean up after all this. And the next step, after I get rid of all the dust and mess I made putting these up, is to put the diffusers on there. And then I just need to adjust the wiring over here, which is a bit of a mess, so I'm going to run that neatly down the corner or something like that. And then we'll have it. And the rest of the project will be entirely about how to do the software. And it's pretty smooth too, so I'm happy with this, very happy with this. It was a lot of work. It's Sunday afternoon, but I did it. It's on the wall. I want to stop in the middle here so we can kind of see work in progress on the diffuser. So on the left side there, obviously, that's with the diffuser. On the right side is without. And I'm just using printer paper taped to the front of it, which worked pretty well. Got it set up here. I've got my paper cutter with a stop there so I can make all the sheets the same size. And basically I'm just cutting out of plain old printer paper, and these go up there. And on the back of it, I'm using the 3M tape application thing to put strips of tape on the edges, and then just hold it up there carefully. Try to align the edge. This is the hardest part, is getting that edge. If it overlaps, it looks terrible. If there's a gap, it looks terrible. So it has to absolutely perfectly butt up against there, which is really hard to do when it's got tape on the back. And as soon as it touches the thing, it gets stuck. But you can see it's possible to do a pretty good job. There's what happens if you have a gap, though, and if you have any overlap, that doesn't really work either. The good thing about this is that it is entirely removable. So I can just peel that off and put something else up or do it again sometime. So I just want to get this done and move on to dealing with the software. I'm not going to worry about minor mistakes here, because someday when I feel like I want to spend hours on it, I could just go through and try to get everything perfect. So anyway, that's the diffuser in progress. And that's Vector. He keeps making noises because he wants to play. And there it is. I think that pretty much covers the installation up to the finished product, which you've seen behind me. I will put the files for the things like this grid and the installation jig and the brackets and things like that in the GitHub repository. I don't think they're there right now as I'm recording this, but I will make sure that they do make their way onto there. The one thing that was not included in that section, because I didn't have it yet, was, as I talked about, I was using this ESP32 development board temporarily, but I needed something that was properly designed with level shifters and resistors and all that for actually driving these things. So rather than try to build my own, I just bought this, which is the QuinLED DigQuad. This is an excellent board for exactly this purpose. It's made for LED strips and things. So it has the ESP32 module on it. It has 4 outputs with nice screw terminals for attaching things. It even has a power section where you can feed the power through a bunch of fuses. And it's all ready to go. So I swapped this in, didn't have to change any code or anything, and it just worked great. So that was my solution. And I also, while I was at it, I remixed the DIN rail connector that I found for the power supply. There wasn't one for this board, so I just took that same thing and I added a little plate to it so that this can screw onto there and then can go on the DIN rail next to the power supply. And that is what ultimately you see over here in the corner. If I shine the flashlight on it, that is the setup. And that's what I've got for this one. So that covers the installation and the hardware aspects of putting this thing up. If you've enjoyed this and you want to make sure you see the next video that comes out about the code, a good way to do that would be to subscribe to my YouTube channel. And either way, I hope to see you again in the next one. Bye.